Today's topic is osmosis. At the end of this lesson, you should be able to predict the direction of water movement into and out of cells. How to cure a sore throat. Gargling with salt water relieves some of the pain of a sore throat, but have you ever wondered why? Why should you gargle your mouth with salt water when you have a sore throat? Well, at the end of this lesson, hopefully you will be able to answer it. Osmosis. Osmosis is a type of diffusion. Remember, we talked about diffusion in the previous lesson? Diffusion is the movement of substances from an area of high concentration to the area of low concentration. Well, osmosis is a type of diffusion, but osmosis only deals with water. So, to help us understand osmosis better, learn this term here. Salt sucks. Let me tell you what I mean about that. When there is more salt on the inside of a cell than on the outside of the cell, well, the cell sucks in water. When there is more salt on the outside of the cell than there is on the inside of the cell, well, it pulls the water out of the cell. So water moves in the direction of the salt. So the water moves in the direction of the solute. Let's talk about 3 ways water moves when it's concerning cells. We will talk about hypertonic. That's when more solute is on the outside of the cell, and hypotonic when there is more solute in the inside of the cell. And also isotonic. This when there is equal amount of solute on the inside and on the outside of the cell. First, let's talk about hypotonic. The word hypo means less. In this case, there are less solute or water, or salt molecules on the outside of the cell. Since salt sucks, water will move into the cell. Since there is more salt on the inside of the cell than on the outside, the cell will gain water and grow larger. A cell can grow so large by gaining so much water, it will burst. Just look at this illustration here. This cell has 20% salt on the inside, but the environment only has 10% salt. Well, the salt will suck in the water into the cell. So where there is more salt, the water moves. Think about it. When you have eaten so much salt, do you get thirsty? You want more water. Well, salt is thirsty. Salt wants water. Hypertonic. The word hyper means more. In this case, there are more solute or salt molecules on the outside of the cell, which causes the water to be sucked in that direction. Water moves out of the cell, causing the cell to shrink. Look at this illustration. This cell has 10% salt, but the environment of this cell has 20% salt. So this environment with 20% salt will suck out the water out of this cell. You get the picture? More salt, well, that's the direction the water will move. But in isotonic situation, there is an equal amount of solute or salt on both sides of the cell membrane. The salt on the inside of the cell equals the amount of salt on the outside, causing an equilibrium. That means there is an equal amount on both sides. Look at these illustrations here. This red blood cell is in an isotonic situation where there is an equal amount of solute on the outside to the inside. They're equal, they're in balance. But in a hypertonic situation where there is more solute on the outside than on the inside of a cell, well, the water gets sucked out of the cell, causing the cell to shrink. In this situation, that it would cause the cell to grow smaller. And also, in a hypertonic situation, is how we preserve meat. You ever wonder why people put salt on meat to preserve it? Well, that salt would draw out all of the water out of the cells, thus creating an environment where bacteria cannot survive. That salt would suck out the water and killing the bacteria. In a hypotonic situation, there is more salt on the inside of the cell than on the outside. So the cell sucks in water. Remember, water goes into the direction of the most salt or the most solute. Well, it can keep on moving across that cell membrane into the cell until the cell bursts. On a sheet of paper, bring to class tomorrow your answer to these two questions. A marine fish has about 1% salt in his body. The ocean is about 3.5%. Will water move into or out of the fish? Question number 2. A freshwater fish has about 1% salt in his body. Fresh water is close to 0% salt. Will water move into or out of the fish? You know, in the first beginning of this presentation, I asked you, why will gargling with salt water relieve some of the pain of a sore throat? What causes your throat to hurt is the swelling. The cells in your throat are filled with water, causing pain as the water pressure builds in your cells. Well, the salt draws out the water out of the cell, causing the swelling to go down, thus causing the pain to decrease.